All right, so here's our scenario. We have a right cone with a height of 15 feet, diameter of 10 feet, and then it's filled with some water that's also in the shape of a cone, although I don't know how water would be any other shape without defying the laws of physics. But that water has a height of, let's fix that, h, and a radius of r. We also know that the water's volume is 27 pi feet cubed at noon, and it is leaking water at a rate of 12 feet cubed per hour at noon. And we're being asked, what is the height's rate of change at noon? So since we are dealing with a cylinder here, I'm going to go ahead and set up an equation for volume, which is just 1/3 pi r squared h. Now, in order to find this rate, we're looking specifically for height, or rate of change of height. So the first thing I'm going to do is try to rewrite this equation in terms of just height. I'm going to try to kind of get rid of my radius right in terms of height. And we can do that by recognizing that since this is a right cylinder, we kind of have right triangles, and we can create a nice little equation with similar triangles. So my diameter is 10 feet, which means, of course, my radius is only 5 feet. So I can draw a nice big right triangle here that has a height of 15 feet and a radius of 5 feet. Now these are similar triangles. This smaller triangle here and the overall large triangle. So I'm going to go ahead, draw the smaller right triangle here. Okay, and it has radius r and height h. Now, since they're similar triangles, we can use that and just make a nice little proportion. So 5 over r, or r over 5, I'll do r over 5, is going to be equal to h over 15. Okay, we'll cross multiplying here. Now there's multiple ways of doing this. I just like the proportion method. So 5h equals 15r. Okay, and I want what radius is in terms of height. So I'm going to go ahead and solve for radius. We'll go ahead and divide by 15. So I get just a little reduction there. 1/3 h equals r. All right, so now I'm going to take this right here, and I'm going to substitute in for r. So now I have v equals 1/3 pi and 1/3 h squared times h. Okay, let's simplify that a little bit. V equals 1/3 pi times 1/9 h squared times h. And let's see, combine our fractions there. So 1/3 times 1/9 is 1/27 times pi. And then h squared times h is h cubed. Okay, so what I want to do next is I want to find out, before I get into any related rates here and take the derivative, I want to actually find out what my height specifically is. The reason being, I have two variables right now. I have v and I have h. So if I take the derivative in terms of time, I'm going to end up with dv dt over here and dh dt over there. And I want to just solve for dh dt. I don't want to have any extra stuff going on there. I just want one rate, not one rate in terms of another rate. Okay, so let's go ahead and solve for height, and that's where this comes into play. We've got our water volume. It's 27 pi. It's equal to 1 over 27 pi h cubed. Okay, now let me slide that down a little bit. All right, so we'll go ahead and multiply both sides by 27 to cancel out my 1 over 27 there. Okay. All right, go ahead and divide both sides by pi. Cancel that out. Sorry, my pi symbol's getting a little messy. So now I have 27 times 27, so 27 squared equals h to the third. Now I'm going to use a little exponent magic here to simplify this quite a bit rather than expanding out 27 squared and trying to find the cube root of it. I'm going to say, well, 27, that is the same as, sorry, it is not the same as 9 squared. What am I doing there? That is the same as 3 to the third. There we go. Squared. Okay, so 3 to the third squared, that's the same as 3 squared to the third. All right, those are both 3 to the sixth. Okay, take the cube root of both sides. Now, if you're really knowledgeable about your cube roots, you can just expand 27 squared out, or if you have a calculator, I just like doing it by hand this way. So cube root of 3 squared cubed is 3 squared, and we're taking the principal root here, presumably, so we'll just get a positive value. So 3 squared equals h, so 9 equals h. Okay, that means our height when our water volume is 27 pi at noon, well, that is going to be 9 feet. So 9 feet. All right, so now it's time to actually get into some related rates. We now have all the information we need. So I'm going to go ahead, just barely enough room here. All right, V equals 1/3 pi r squared h, just rewriting what I had earlier. And apologies that this is kind of a slanted page. It's just had to move it a little bit for my hand. All right, so let's fill in what we know. And actually, we don't need this. We already have our, I should have taken the version that is written just in terms of h, so I'm going to do that. V equals 1/27 times pi h cubed. So we don't really need that. All right. Now, let's go ahead and take the derivative of both sides because, of course, I'm trying to find the value of dh dt. So take the derivative of v with respect to time. Well, that's just dv dt. It's just a good old power rule, single variable. All right, equals 1/27 times pi. And then we've got power rules, so subtract 1, we get times 3h squared. Okay, a little simplification. 1/27 times 3, well, go ahead and reduce a little bit, so that's just 1/9 pi h squared, and this was my bad. Of course, this is times dh dt because we're taking it with respect to time. Been a little while since I've done problems like these. All right, I'm running out of room here, but we're almost there. So I actually have this right here, right? I don't want two rates here, so I'm going to go ahead and drop in the leak rate of 12 feet cubed in for dv dt. Okay, 1/9 pi h squared dh dt. Okay, and I'm going to go ahead and drop in my 9 for h. So 12 equals 1/9 pi times 9 squared. Oops, what am I doing there? dh dt times dh dt. All right, I'm going to snag another piece of paper here. Put that in there. All right. There we go. All right, simplify it a little bit. 12 equals 1/9 pi times 81 times dh dt. And at this point, it's just a little algebra, a little simplification to solve. 81 times 1/9 is 9 times pi times dh dt. We'll go ahead and divide by 9 pi. Okay, and our last move is, let's slide that a little bit, 12 over 9. Well, that's 4 over 3, also over pi, equals dh dt. Now just to go back to where we started, we're being asked what the height's rate of change is at noon. So it's going to be, with our unit, 4 over 3 pi feet per hour. Now this is a positive value, but depending on your particular teacher, since our rate is headed in the negative y direction, since gravity heads downward, your instructor may want you to have this as a negative value, but direction isn't really specified, so I like to just leave it as a positive value. Whoops. All right, so that's it. Hope that helped.